Dear students, welcome back. In the previous session, we have discussed about full wave rectification. Now in this session, we are going to discuss about smoothing circuit. I have already mentioned about this smoothing circuit in the uses of condenser. So the smoothing circuit is containing capacitors actually, so which is used to reduce the variations in the intensity of a rectified current. So that means already the current is rectified by rectification, then also in the intensity it is having some variations which may cause unpleasantness to the patient. So to reduce that variations in the intensity, so the smoothing circuit is used. Okay, it consists of two capacitors, okay, which helps in to reduce the variations in the intensity of the rectified current. Okay, now we will see the construction of this smoothing circuit. The circuit consists of normally one or two condensers wired in parallel to the output circuit. So these are arranged in parallel to the output circuit. Okay, and a choke coil is in series. So here the connection is there. A choke coil is, so C1 and C2 are connected parallel to the output circuit, and the choke coil is connected in series with the circuit. Okay. So when the EMF of the rectified current rises, current flows in the external circuit, and at the same time the condensers are charged. When the EMF falls, the intensity of the current in the output circuit falls, but the condensers discharge round this circuit, and it does not affect the flow of current, so that the intensity does not fall to zero. Okay, normally what is the main function of this capacitors? To hold, to store the electric charges, isn't it? If there is any fluctuations also, these capacitors are going to supply the flow of electrons so that the intensity does not fall to zero. So thus the variations in the intensity of the current are reduced. The condensers have a large capacity so that they offer little impedance to the charging current and hold a considerable quantity of electricity to discharge round the circuit. As the current varies in intensity, an induced EMF is set up in the choke coil. When the intensity of the current is rising, the self-induced EMF opposes the applied EMF and retards the rising current. When the intensity of the current is falling, the self-induced EMF is in the same direction as the applied EMF and prolongs the flow of current. So these effects further reduce the variations of the intensity of the current. Okay, so because of all these things happening in this smoothing circuit, which helps the patient to feel a smoothing effect. Okay, though the current that is obtained from the smoothing circuit also varies very slightly in intensity, but it is still suitable for constant direct current treatments. Okay, this is about the smoothing circuit. Thank you.